In this video, we're going to talk about antiderivatives. And as the name suggests, antiderivatives are the opposite of derivatives. So the process that we'll follow for finding antiderivatives is the exact opposite process that we've used for finding derivatives. And this process of finding antiderivatives is also very important in our study of calculus. So far, we've been studying differential calculus. But going forward, we'll see how anti-differentiation leads us to the second main branch of calculus called integral calculus. And this process involves us being able to find an original function, f of x, when we're given its derivative, f prime of x. So for example, if we want to find the antiderivative of f prime of x is equal to 2x, we have to reverse our thinking. In other words, we have to think backward. What function has a derivative of 2x? Well, this one's not too difficult. We can rewire our thinking, think backwards, and we'll see that a function f of x equals x squared. Well, that's the function that has a derivative of 2x. But this should raise another question in our minds. Is x squared the only equation whose derivative is 2x? What about the function f of x equals x squared plus 2? That function has a derivative of 2x as well. What about f of x equals x squared minus 3/5? That function also has a derivative of 2x. Just like the function f of x equals x squared plus e. That function also has a derivative of 2x. So as we can see, there are infinitely many functions that have a derivative of 2x, because there are infinitely many functions of x squared that only differ by a constant. So that creates a small problem for us. If we're given a function 2x and we want to find its antiderivative, there are infinitely many answers to this question, because there are infinitely many variations of x squared plus or minus a constant. So we fix this problem by saying that the antiderivative of 2x is x squared plus c, where c is any constant. So as we move forward and we find antiderivatives of different functions, it's important that we always add a plus c to the end of our antiderivatives. Okay, so how mathematically do we notate the process of finding an antiderivative of a function? To do that, we use what's called an indefinite integral sign. That's this sign that looks like an elongated S. And in fact, it is an elongated S. And we'll talk more about that in future videos and why it's significant that this symbol looks like an elongated S. So anytime we want to find the antiderivative of a function, we'll see this elongated S at the beginning of the expression. The next thing we'll see is what's called the integrand. And the integrand will immediately follow the indefinite integral sign. And the integrand is just the function that we need to integrate. And then lastly, at the end of the integrand, we'll see the differential dx. And for now, this dx just tells us the variable of integration, or the variable that we're integrating with respect to. Now that we know the basics of antidifferentiation, in the next video, we'll do some examples.